So dear students, let me continue our discussion on normal reaction. In the previous class, I have discussed about some basic properties of normal reaction. But now in this class, I like to discuss about some application of normal reaction. And the applications which I am going to discuss in this video will actually appear in various problems when we want to solve problems based on Newton's law. Then we will face these types of picture, these types of diagram where normal reaction arises. Okay, so I have given here some example on this, and with these examples let us understand about normal reaction, how we have to choose the direction of normal reaction. That we will discuss by these diagrams as you have seen in figure. Okay, so in previous class, the properties of normal reaction, when we have studied about properties of normal reaction, we understand that normal reaction is always normal to the contact surface. Here in the first figure you can see that here the object is contact with this surface. Okay, with this surface, object is contact with this surface, and the surface react with this reaction force that is perpendicular to this contact surface. That is actually normal reaction. So in general, in very basic form, you can say that normal reaction is always perpendicular to the contact surface. But it is not necessary that the normal reaction will always act through the center of mass or through the center of gravity of the object. Here in the first figure you can say that the normal reaction is acting at the middle point of this object, so that this normal reaction is passing to the center of mass of the object. But it is not necessary that every times it will look like this. For example, in this figure you can say the normal reaction is shifted towards right from this middle position, and this is due to the force capital F, due to this force capital F. Here also you can say from this figure that here the center is this. Okay, center of gravity or the center of mass of the object is this, but the normal reactions are acting here. So from these examples, from these various examples, you can say the first point, the normal reaction is perpendicular to the contact surface, but it may or may not be passes to the center of mass. And here you can see, if we investigate the reason why here the center of mass, here the normal reaction is acting to the center of mass. Actually, normal reaction force will arise at each and every point of the contact surface. So if you talk about these points, so there are a large number of points which are contact with the surface. So at each and every point a normal reaction appear. But due to the symmetry of the picture, you can say that each and every normal reaction are similar, same in magnitude. So the resultant force will be must be at the middle point. The resultant force N must be at the middle point. But if we give a little bit of force from this side, then what will be actual thing? The weight of this object, here the normal reaction is basically due to the weight of the object. So each and every point feels a same force because the weight or the mass is distributed symmetrically throughout the object. So at each and every point, the downward force that is given by the object to the surface is same. So the surface will react with the same force at each and every point, so that all the normal reactions are same and the normal reaction is acting at the middle point. This is actually the resultant of all this force. But here, if we apply a force from this side, then the weight is shifted. Okay, because if we push the object from this side, then the contact between the object and the surface, this side, will be less because here is a force. So the weight will be shifted this side. Suppose you can say, if someone push me from this side, then what will be think? I will be shifted this side. So my weight will be shifted this side. So the normal reaction will be shifted this side. Okay, similar case is here. If we give a force, then the weight is shifted in this side. So the most of the forces is acting in this side. So the normal reaction is shifted from left to right. And you can imagine that if you give more and more force, then one times the normal reaction will be at this point, this contact point. When this contact will be lost, all this contact point will be lost, and if you apply this force more, then the body will topple down. You can realize this thing: if someone force me from this side, then my normal reaction is shifted, and after some time I will be toppled down in this side. But what I have to do, if we resist the force, or if we want to resist me to topple down, then what will be the process? We just sometimes extend our legs like this. Why we extend our legs? We extend our legs. This is because such that the normal reaction have to travel more distance. If the object has a large surface area, then the normal reaction has to move more distance from this side to this side. So the required force will be more. So when I prevent myself to topple down, what is the process? I have to extend my leg such that the normal reaction have to move more distance. So the person who will push me have to give more and more force, so I can resist him by using this thing. Okay, so this is actually the thing here. These two diagrams explain that normal reaction for symmetric object and for symmetric contact, the normal reaction is acting through the center of mass, but it is not necessary. Okay, because it will depend the force that is given by the object to the surface. If the force given by the object to the surface is symmetric, then the normal reaction will act to the center of mass. Otherwise, it may act at any contact point. But wherever there is a contact point, the normal reaction is act, and the normal reaction is always perpendicular to the surface of the contact. Okay. Now, if we see this diagram, here you can see only two contact point is there. One is here and another is here. So only two normal reaction is appeared. And at this point, the normal reaction is perpendicular to this surface. So this is N1. And for this point, the normal reaction is perpendicular to this surface. So this is N2. Okay. So here, this is the contact surface and this is the perpendicular. And this is the contact surface and this is the perpendicular. So 2 point of contact, 2 normal reactions are appeared. Here actually a large number of normal reactions are appeared. But the resultant of these will be N. But here only 2 points and 2 normal reactions. And these are in the different direction, perpendicular to each other. But sometimes what will happen, you cannot find the normal to the contact surface like this. Here, if you see this diagram, here the normal to this contact point is N1 because here the surface is this. So we can easily find out the normal to this contact surface. But here at this corner point, you cannot find the normal to this point. So what will be the process? You have to make the normal reaction. You have to draw the normal reaction to perpendicular to the object. If you cannot find the perpendicular to the surface, you have to do the normal reaction perpendicular to the object surface. So this is the object surface and this is the contact point. But in this contact point, there is no perpendicular, there is no normal. But if you see this plane, this is the plane of the object, but here there is a normal. So this will be the direction of the normal reaction. This is, you can say, a trick. Okay, I will tell you why this trick is used and why this works so well. Okay, I will tell you. And to explain this thing, let me choose a diagram where you cannot find the normal to the surface as well as you cannot find the normal to the object. That is at this point. If you consider this point, then what will be the case? At this point you cannot find. Here actually this is the surface, you can say, and A is the object, and this triangular wedge, the block A is placed on this triangular wedge. But at this point, if you see that there is, if this point there is a normal, you can easily find a normal. But this corner point or this corner point, you cannot say in which direction the normal is acting. So you cannot find the normal to the surface as well as normal to the object. Here the object is A. Okay, so there is no normal to the object. You cannot find normal to the object. You also cannot find the normal to the surface. So what you have to do, you have to resolve this normal reaction into two components. And this is the basic thing of vector resolution, because normal reaction is a force, this is a vector quantity, and any vector quantity can be split into two perpendicular components, that is called the perpendicular resolution of vector. So here the normal reaction will be somewhere over here. We don't know where is the normal reaction, but whatever be the normal reaction, it should have two components, one is along x-axis and another is along y-axis. So we can easily draw nx and ny, and if we can find nx and ny, then we can easily find the resultant n, that is nx square plus ny square, and we can also find the direction, that is if this is the normal reaction n, then we can find tan theta is equal to ny divided by nx. This is ny and this is nx, so if this angle is theta, then tan theta will be ny divided by nx, then we can easily find out the actual direction of normal reaction. So at any point, this is the general method, you can say this is the general method, because at any point if you draw two perpendicular component of any force, then you can find the resultant force in magnitude as well as in direction. So when you don't need to this splitting of these components, so there will unnecessary more variable is arised, because in problems always what we have to do, we have to reduce variables. If there is a large number of variables, then we need large number of equations to solve. So what we want to do, always we want to do reduces the variables. So if there is no need of splitting nx and ny, we will not do, because here you can easily find the normal reaction directly, here also easily find normal reaction directly, so you don't need to splitting like this. But here we have to know, we have no choice, we have to split nx and ny, because you don't know the actual direction. Here also we can, here easily you can find out n1, but here we cannot find the direction of normal reaction. So we use a trick that it will perpendicular to the object. This is not the actual definition or the actual property of normal reaction. The property of normal reaction is always perpendicular to the surface, contact surface. But here we have drawn the normal perpendicular to the object surface. This is not the actual thing. But why we have used this trick? Because if you draw two perpendicular, one is nx and another is ny, then the resultant will must be in this direction. Actually we skip this step. Why? This is simple, we want to reduce the variable. If we split two components into two components nx and ny, then one variable is extra here. Two normal reaction, we have to solve for two normal reaction, so we need one extra equation. But if we draw this kind of normal, then we don't need these things. So we will use this trick always, that whenever we cannot find the normal to the contact surface, but if we can find the normal to the object surface, then we will do this. This will automatically match with this general process nx and ny. But for this kind of situation we cannot do. Similarly here, if you see, this is a round shape ball like this, it will be moving from this side to this side, it will be actually rotation in rotational motion with angular frequency omega or angular velocity omega. It will face this type of object, and here you can say two contact point is there, one is here and another is here. So here we can draw easily normal to the contact surface. This is the contact surface, so we can draw the normal, that is n1. But here at this point of contact, we again cannot find the normal to the contact surface, because this is again a corner point like this. We cannot find the normal reaction. So what we have to do? If we find the if we can find the normal to the object, so what will be the normal to the object at this point? This is a sphere. Okay. So if we draw a tangent plane over here, then at this point the normal will be tangent, the normal will be normal to this tangent. This is the tangent and this will be the normal to the tangent, and that will be the normal reaction at this point, at this contact point. Because whenever you can draw a normal like here if you want to draw a normal here, so you have to draw a tangent first, then with this tangent this will be the normal, and all the normals always will pass through the center because these all are radius. All the radius of a sphere or of a circle will always perpendicular to its tangent, and all are passes through the center of mass or the center of the object, will be passing through the center of object. Here actually the contact surface is itself a tangent. At this point this contact surface is itself a tangent, so we can easily draw n1 over here but not here. Okay, so these types of things, these types of diagram will arise in the problems, and you have to keep in mind all these things such that you can easily draw the normal reaction and solve the problem. Okay, and here is one important thing, that when there is no contact with the surface, the normal reaction will be 0. This is the obvious thing, because I have said earlier that normal reaction is basically a contact force. So whenever there is no contact with the surface, the normal reaction will immediately be 0. Here, whenever the object is here, there is a contact, here there is a contact, but at this point there is no contact with the surface, so at this point normal reaction will be 0. Similarly, in a lift, I will tell you later on, in a lift, if there is an object and if there is certain acceleration of the lift in downward direction, that is g, then we can see that n is equal to 0 over here, so that the object will no longer remain on the surface of the lift, or the floor of the lift. It will lift the surface because the normal reaction will be 0 here. So this concept we will use vice versa, that if there is normal reaction is 0, then we can immediately conclude that there is no contact with the surface of the object, and if there is no contact with the surface of the object, then normal reaction will be 0. So we will use in many problems this concept of vice versa. Okay, so these all are the concepts of normal reactions. Okay, so we will use these concepts large number of times in problems, so please keep in mind these concepts. Okay, thank you.